PCG isn't meant to do this. Procedural Content Generation is a system designed to create rules for populating a world with assets. It can be with foliage, it can be with buildings, or even asteroids. What it's not designed to do is animate. But when I saw in a recent talk that you can send commands to the PCG graph to regenerate, it made me wonder if it could be used for animation. I found some reference footage that I really wanted to see if I could replicate, and then I went from there. Jump into Unreal 5.2 and launch a new project using the newly updated Motion Graphics default project for 5.2. There is a link in the description. These are the plugins you need to tick on: Procedural Content Generation Framework, Geometry Script Interop, and of course, Geometry Script. So I'm just going to create a new folder for this. I'm going to call it PCG. After you've enabled the plugins, you'll have a new menu here. So now we've created our PCG graph, I'm just going to drag it into our level so we can see what we're doing. Now, you may have noticed that as I dragged it in, created this box. That's kind of like an inbuilt volume in which the PCG graph will be acting. Or if you just chuck down a surface sampler, it will first off default to sitting on top of the volume because that's what it's going to interact with. Let's double click on the graph to open it up, and you'll see, kind of like blended geometry nodes, there's an in and an out, but as you'll see, that's not necessarily what you have to use. Just to start off with, we'll put down a very simple surface sampler. I right click, start typing, and then I can choose surface sampler. For the moment, I'm going to just use the in, and nothing happens. So what have we got to do? Well, we have to learn some keyboard shortcuts. If I hit A to show the attributes, I can see that there's nothing here. It actually needs to look at a PCG object to be able to debug. And now we see that there are all of our points that this surface sampler has generated. But the thing is, I still can't see any of them. They are there, but if you hit D, which shows all of the points using a debug cube, they are kind of in a grid and kind of a little bit loosey-goosey. So what I'm going to do, just so we can accurately see what's going on, is I'm going to increase the number of points per square meter. I'm going to decrease the extents. So we have a bunch of points. And then I'm going to set the looseness to 0. That gives us a nice, almost Minecraft-esque kind of lattice of points. But what's with the noise texture? Why is it this kind of static-like texture? Well, that's because on generation, every single point gets what's known as density. If you scroll all the way to the right in your attributes, you'll be able to see that the density column has a number between 0 and 1. And that's what this level of brightness is showing. This dark one will be close to 0, and then this light one will be close to 1. So now we can see our points, and we can see all of their attributes, which is very Houdini-like if you've ever used that. We can start to do stuff based on those attributes. You could transform these points, but it kind of doesn't seem like anything's happened. That's because the debug switch is still on surface sampler. So I'm going to select this, hit A and D to get rid of that, and then I'm going to hit A and D on my transform points. And you can see that we now have beautifully randomized, scaled cubes. So as I mentioned earlier, it's just putting the cubes on top of this volume. So what we're going to do is we're going to add a world ray hit query. What's interesting is that I'm going to connect it to the surface and disconnect it from in. Now, what world ray hit query does is that inside this volume, it will fire off a ray and it will generate the points based on the impact. Unfortunately, it hasn't quite impacted in the way that we were hoping. So if I select the world ray hit query, I'm going to override the default parameters. I'm going to change the ray direction to 0.54, 0, and leave that as -1. But of course, it's still not quite hitting. So if I dial down advanced, I can turn on trace complex. And now we're getting points that intersect with our studio. Now, if you've used Cinema 4D before, you'll recognize this kind of a setup. It feels a lot like a cloner. And kind of the first thing that you want to do after you've cloned stuff is you want to reach for the random effector, because then you can just animate things and make them move in an ambient kind of way. Overall, what I really want to try and head towards is something like these undersea creatures. I want some pulses that like travel out from the center that really bring attention to the main title and allow us to create a lot of interest without having to manually animate every single one of these cubes. We've already added some randomness by adding a transform points node. But how do we animate these? Really, all we can do is just set a minimum and maximum. Now, we could fight this, or we could go straight into creating a custom PCG node. Now, before you get scared off, I did warn you, we are just here to break stuff. So, right click, go to Blueprint class, and then we're going to have to dial down all classes and search for PCG, come down and choose PCG Blueprint Element. Now, there isn't really a naming convention for this just yet. Like, I had a look through the Unreal Directive. You could call it BP _ custom loop _ PCG, but that might make it a little bit confusing later on as we need to create another blueprint. I'm going to leave this as it is for the moment. Leave me a note down in the comments if a different name is going to be better. Let's double click on this. And we have nothing that would suggest to us what to do next. The one thing that we do see is over on the left, underneath functions, there's a drop-down list of the 9 functions that can be overridden inside this kind of blueprint. We're going to be overriding the execute with context and also the point loop body. Execute with context is kind of just what happens every single time this node is connected up in a PCG graph. Now, I learned all about this from a wonderful video from another YouTuber called Freetime Coder, and he provided the kind of boilerplate code that will allow you to break apart each point and put it into a point loop. And underneath his video, somebody else suggested a different way of setting things up, just using a slightly different node. I've created an account on Blueprint UE, which is an amazing website that allows you to copy and paste Unreal Engine graphs straight into the browser. So the way that you can get access to this is basically just click and drag and copy, and then you can paste it. Okay, so that's come in without too much hassle. And what I'm going to do now is just going to recreate what I have here in Blueprint UE. So you'll notice that sometimes in Unreal, pin lines can go behind other nodes, which makes it very, very hard to sort of see where things are. So just be careful of these 2 nodes. There is a thing running behind it. So I'm not going to go into too much detail because Freetime Coder does a really good job in his YouTube video. So once you've got everything hooked up just like it is in the Blueprint UE website, hit compile and save. And what we're going to do now is we're going to come into the point loop. So double click on the point loop body. And very, very importantly, we need to tick return value, because without that, it actually doesn't return anything, I found. And you'll be staring at a blank screen for a long time. For the moment, this is all that the point loop does. It takes in each point and spits back out again and returns it, which is very important. If I come back to our demo graph, I can now drag in this BP custom loop, and I'll just delete this transform point, and I will connect it up to the BP custom loop, and I will just check that yes, it's still outputting points. And if I debug it, it shows me that without the transform nodes, I'm just looking at my straight points. So it hasn't done anything, which is good. So back in the point loop, what we're going to be doing is breaking apart each point and then putting it back together. So here, if we just drag out this in point, I can search for a break PCG point, which gives us all of the points details. Most importantly, we'll be looking at transform and density. If I drag out the transform, I can break it as well into its location, rotation, and scale. Of course, we need to put everything back together. So at the very end, we would need to make a transform, connect everything back up. And then to To put it all back together, we'll be using a set members in PCG point struct. It is a bit confusing that these are named differently, like breaking it apart. You would think you would just use a break and then a make, but I'm sure that there's a reason for it, or else it's going to be renamed in 5.3. But you'll notice that the set members doesn't have the really nicely laid out information like the break PCG point does. That's because up here, after we've selected it, we'll need to open up the properties and turn on transform. So now we can send this back in. We do need to give it the point that we're talking about so that it can set things, and then we set that to the out point. So now we can see that we are breaking apart a point. We can do stuff to it here, and then it will be put back together, put back into the point, sent back out to the actual PCG graph. After I compile and save, nothing has happened yet. But look what happens when we multiply the scale by the density. Compile and save. Now we're getting somewhere. We can see that the scale of 1 has been multiplied by its density. So now, if we come back to the demo graph and have a look at its attributes, the scale is now reflective of whatever the density is. Now we can start to do some fun stuff. Just so we can control it a little bit more without having to come back up, I'm going to add a pin. I'm going to right-click and say convert to float, and I'm going to promote that to a variable. I'm going to name it scale magnitude, expose it, and then when I come back after I've compiled and saved, I can now control the scale magnitude. So you can see that if I increase it, obviously it increases the magnitude of the scaling. So I'm just going to leave it at 1 for the moment, but that's going to be useful later on. So I mean, that's cool. We can control the scale magnitude. That's kind of fun, but it's like, how do we turn this into that kind of pulsing that we saw earlier that I really want? We'll need to organize the density a little bit, and then I think that will give us a bit of a canvas to work on. Just after the surface sampler, before the PCG BP custom loop, I'm going to add a distance to density node. I'm just going to disconnect this by holding down Alt and then clicking. I'm going to connect up the distance to density. So distance to density basically does what it says on the tin. You get a reference point and the maximum distance, and then for every point, it will give you a density from 0 to 1 based on how close or far it is from the reference point. I'm just going to set this reference point to 845, 30, and 10, and then I'm going to set the gradient scale to 2300. Now we've got the density being a gradient from very close to 0 when it's close to the reference point, all the way up to 1 when it is far away. Some of you may already realize how this is going to help us create these undulations, but if you can't, just hang on, you will see. Let's jump into the custom loop now, where we can access the sine function. So what we're going to do is we're going to run density through a multiply, then through an add, then a sine radians. I'm going to set the multiplication to 12, and then I'm going to leave this as 0, and I'm going to promote them both to variables. So for this one, I'm going to call it sine frequency, and I'm going to call this sequencer control variable. You may already start to see that we are controlling the frequency of the sine function, and we're also going to be controlling the offset of these waves. So after things come out of the sine, you'll get a result between -1 and 1, but we want it between 0 and 1. So to get that, create an add function where you add 1 and then multiply it by 0.5. So a bit of a fun little thing. When I went to render this, it kept on crashing Unreal. So the only way that I was able to fix it was to add a very, very small amount after this sine normalization kind of thing, so it never went to 0. And that seems to have fixed it. You can also do it using a map range clamped. -1 to 1 now becomes 0.1 to 1, and then return that. Then we feed this into our original multiply node instead of density. And if I compile and save that, come back to our original graph, you can see we now have some undulations going on. And not only do we have undulations, but we also have the ability to control it. So I can make the frequency higher, so there's more undulations. And if I start shifting around the sequencer control variable, it will start to offset those waves, creating the kind of undulations that we're looking for. So from here, instead of using the debug node, I can create a static mesh spawner. And if I add a mesh entry, I can now set this to be some kind of sphere, but I can't see anything anymore. So back on my custom loop, I'm just going to need to change the scale magnitude to something like 10, maybe even 20, maybe even 30. And then I'm going to come back to my static mesh spawner and just override the material with something that we like the Berkshire wine. Yeah, that looks kind of cool. All right, and as we move through the offset, we get some really cool undulations. So we've been through a lot, but how do we actually control it using sequencer? This, unfortunately, is the trickiest bit. But if you can hold on through this, there is honestly not much that you can't do. First of all, we're going to need to wrap this whole shebang up in an actor blueprint. Come back to where we've got things. I'm going to right-click, create a blueprint class, and it's just going to be an actor blueprint. BP underscore PCG pulses. Let's open it up. Now, there's nothing in there yet, so we're going to add two components, a PCG component, and we're going to add a box collision. If you remember back to the beginning of this tutorial, when you drag in a PCG graph, it comes with a built-in volume. This PCG component doesn't come with it, so we have to provide a boundary of some sort for the PCG graph to work within. So it'll respect any bounds of the actor, so we're just going to create this box collision to give it some bounds to work within. Now, on the PCG, all we need to do is come over here to where it says graph, and then we're going to click and drag our demo graph into this section here. Let's compile and save. Always compile and save. And then, deleting our original graph, we're going to drag our new blueprint PCG into what we actually want is it to be covered. Now, if you notice, the box isn't quite large enough, so we'll open up this again, select the box, and we'll change the box extents to be 2000 in every direction. And you can already see in the background, it's starting to work as expected. Now we just have a few more things to set up before we get into sequencer. Back in Blueprint, so underneath variables, we're going to click on the plus button and we're going to add a variable. We're going to name this animation control and we're going to change this to a float. We're going to expose it by clicking the I button. And with this still selected, we're going to come over to the right and tick expose to cinematics. Now this gives us a variable in the top level blueprint, but how do we actually get it into this PCG graph? The answer is that we actually have to grab it inside our PCG graph. We're going to right click and add a node called get actor property. Now, we haven't actually put in anything yet, so it'll just say, warning, in the property name, we need to type in animation control. Now what we can do is, we can use this anywhere inside our PCG graph. If you click this little arrow here to dial down the PCG BP custom loop, you can see we actually have the attributes that we created inside. We're going to hook up this to our sequencer control variable. Click save, come back out to our level, and you'll notice that on our BP PCG pulses, we now have animation control as an exposed property. Changing this does actually work. We can even drag our blueprint down into our sequencer, add a track, and animate our animation control. Let's go from 0 all the way through to 50. But nothing is happening. What's going on? Well, when we change something in editor, it's actually sending a generate signal to the PCG. So underneath PCG, you've got this button that says generate. The one thing we're missing is asking the PCG graph to regenerate every frame. On the BP PCG pulses track, we're going to add a track for the PCG component. Then we're going to add a new event, and it's going to be a repeater. Now just make sure it's covering the entire frame range because we want this to happen every single frame. On this green bar here, you need to right click, go to properties, and under event, there's a drop down box. There, just hover over quick bind, go to PCG component, PCG, and then choose generate. Now, a lot of complicated stuff just happened. Like this is actually the director blueprint, which is the controlling blueprint for the sequencer. And it's just created an event that will send an event over to the blueprint every single frame to make sure that it regenerates. I'm just going to save that, close down, because, oh no, nothing's working. Well, what we need to do is we need to right click, go to properties, click call an editor, and click force. Now, sequencer is controlling our animation. But this is only part 1 out of 2 or maybe more. You will agree that this is a silly way of doing things. You will wonder, well, you'll want to control the material eventually. Why don't you just control all the animation through the material as well? So that way you can have performance and you can have reliability because it's all being done at the shader level. The answer is yes, we can, and you'll learn that in the next tutorial. So stick around.